Hello everyone! Welcome to this channel. This is Pinay Nurse and I have created this channel in order to help nursing students navigate through their courses. For this video, we'll be taking up preparing the data for analysis, which is part of data management in quantitative research. This will include all of the steps that you need to do from the retrieval of your questionnaire up to the tallying of your data. So you have floated and retrieved your questionnaire. What's the first thing that you're going to do? While the respondent is still there, go through the questionnaire and see if there are any omitted responses. If there are, give back the questionnaire to the respondent for it to be completed. What if the respondent is no longer around? Then what do we do with those incomplete questionnaires? Remove these questionnaires with incomplete responses, set them aside. Most likely, you won't be using them anymore. The next thing that you need to do is to count the number of completed questionnaires. If the number is less than the sample size, then float more questionnaires until the sample size is met. For example, your sample size is 100 and you have only 90 completed questionnaires. So you still need 10 more. I would suggest float more than 10. Why? In the future, there's a possibility that you would be discarding more questionnaires. You will have a reserve number. Step 2 is to inspect the data for outliers. What is an outlier? It's an observation point that's distant or different from other observations. Example, in the scores 23, 25, 30, 32, 36, and 5, it's very obvious that 5 is very different. It is so distant from the rest of the scores. Therefore, the score of 5 is considered as an outlier. What do you do when there is an outlier? You have to decide whether to remove or retain it, and the proper action depends on what causes the outlier. What are the possible causes of outliers? First is errors in measurement or data entry. For example, you're conducting a research wherein you weighed 30 adult female participants and the weight range of the first 29 is from 50.33 to 65.75 kilograms, whereas the weight of the 30th participant was recorded at 5.25 kilograms. This is an outlier. But look at it. Is it possible to have that kind of weight? No. Is this an impossibility? A 5.25 kilogram is consistent only for a 2 or 3-month-old baby. Therefore, you committed an error in data entry. Don't guess. Don't say, oh, this is 52.5 kilograms. I just misplaced the decimal point. You are not sure about that, so what is the right thing to do? Go back to the 30th participant and weigh her again. But what if it's no longer feasible or practical to do so? Then, discard the original data of 5.25 kilogram and replace it with the data of a new participant. Another possible cause of outliers is sampling problems. Example, you are studying the knowledge of third-year nursing students in University X on community organizing. You have chosen third-year students because in University X, community health nursing is taken up in the second year for both lecture and clinicals. So you're thinking by the time they reach third year, they are expected to have knowledge already about community organizing. You floated the questionnaires, and when they came back, there were two very low scores, praised to foreign students who have just enrolled this semester. Are you going to include or discard these scores? Upon further investigation, you found out that for these two foreign students, they came from schools where community health nursing is taken up only in the fourth year. Therefore, it is not expected that they will really have knowledge of community organizing. So what do you do with these scores? Discard them. In the first place, these two foreign nursing students should not be part really of your sample because they have a different curriculum. They do not possess the characteristics that you are looking for in your sample. Another possible cause of outliers is random chance, which may include extreme values. To illustrate this, let us go back to the original example wherein you committed an error in data entry of the 30th participant's weight. You wrote there 5.25 kilograms. You realize that this is an impossibility, therefore, you try going back to your original 30th participant, but it's no longer possible to do so. So you got a replacement, weighed her, and it registered 100 kilograms. Comparing this to the weight of the other 29 participants, which range only between 50 to 65 kilograms, this is also considered as an outlier. So the question is, are you going to include this data? To answer this question, ask yourself, is it possible that in the general population, there could really be people who are very heavy or very fat, those who are obese, or some may even be morbidly obese? There are extreme values. The answer is yes. So if this can happen in the general population, then accept the possibility that this can also happen in your sample. Therefore, include that outlier. Step 3, identify the data to be recorded. When recoding data, transform nominal variables to numbers. Nominal variables are variables that are not ranked. They are just names, they are just labels. Example, in a research, gender is the nominal variable, and males given a code of 1 and females given a code of 2. Both 1 and 2 have no value. It does not mean that just because females are given a code of 2, that they are doubly superior to males. No, they are just used for categorization of the participants. So that when you enter the data into your statistical software, the software will be able to categorize or separate those that are given a code of 1 from those that are given a code of 2. Another form of data recoding is to perform reverse scoring. Here, negative items in the questionnaire are given the opposite values when recoded. For example, the research question is how extensive is the support system available to adolescents? We floated the questionnaire. The instruction is read its statement and write a number that corresponds to your extent of agreement or disagreement. 1 is strongly disagree, 2 is disagree, 3 neutral, 4 agree, and 5 strongly agree. Let's see the items in the questionnaire. A. I belong to a group in which I feel important. This indicates the presence of a support system. B. Someone close to me makes me feel secure. Again, this indicates the presence of a support system. C. I have no one to talk to about my feelings. This indicates the absence of a support system. D. I have at least one person who will be there when I need help. Again, this indicates the presence of a support system. So among the 4 items, A, B, and D all indicate the presence of a support system, whereas item C indicates the absence of a support system. Therefore, item C will have to be reverse scored. So how do you do reverse scoring? If the scores are 1, 2, 3, 4, 5, then the reverse score would be 5, 4, 3, 2, 1. To illustrate reverse scoring, let's go back to the items in the questionnaire. Let us assume that the respondents' answers are the ones in blue. We have to reverse score item letter C. I have no one to talk to about my feelings because this is opposite the other items. It indicates the absence of a support system. The respondent scored it as 1, then we score it as 5. The other items will be scored the way the respondent answered them. Step 4, tally or encode the data. When there are no right or wrong answers, example, when assessing attitudes, beliefs, or perceptions, encode the number that corresponds to the participant's answer. Let's go back to this example again. What are we going to encode? For letter A, encode 5. For letter B, encode 4. For letter C, encode 5. And for letter D, encode 3. But when there are right or wrong answers, example, when assessing knowledge, encode 1 for a right answer and 0 for a wrong answer. For example, the research question is what is the extent of knowledge of K-12 students on reproductive physiology? The instruction is put a check mark to indicate if a woman is fertile or infertile during these periods. For both of these items, the correct answer is infertile. But let's say the respondent checked fertile for item number 1. Since this is the wrong answer, then encode 0. And let's say the same respondent checked infertile for item number 2. This is the correct answer, so score it as 1. When you're done tallying, then you're ready now for the next step, which is putting your data under statistical analysis. I hope this video has helped you. Please hit the subscribe button. Thank you very much.